This is my presentation for the pattern recognition course. Uh, the project for my project is driver drowsiness detection using ER ratio with an implementation in OpenCV. Uh, dlib is the library pre-trained model in Python. The problem statement for this project is that there are a number of cases, there are a number of accidents which happen every day due to the driver drowsiness. Even a distraction of 2 seconds can lead into an accident. As you can see, the figure shows that there are an alarming rate of the accidents that are there because of the drowsiness. The statistics has been taken over the internet, and so now my project is trying to find out the solution of this problem. So it starts with finding the object pose, which is the driver. So face features are detected using the predefined model, which is the dlib. The input is taken from the webcam, which is presently the webcam of the laptop. The 3D model which is captured has 58 points for the face features, and there are total some points which are same in the 3D and 2D model, and this 58 points are converted into the 68 points. Uh, Finally, the rotation vector matrix and projection matrix are also calculated. The Euclid angle have been calculated to detect the moments if the driver is facing the camera or not. There are three moments which can be detected using the Euclid angles. And finally, the absolute value of all three angles are taken. Um, and individual values are also compared if there it is less than threshold, and the total absolute value is also compared so that the driver is facing the camera or not. An eye aspect ratio is a ratio which tells us whether what is the ratio between the length and the height of the eye. So it helps us to determine the eye openness, and it is calculated using the formula that has been shown in the slide. Similarly, mouth aspect ratio is used to calculate if the mouth is open or not. So if the mouth is opened for a long time, which shows that the driver might be yawning, which is also a sign of drowsiness. So mouth aspect ratio is calculated, which is as height of the mouth to the width of the mouth. Then a threshold has been set for MAR because there might be cases when the driver is just yawning. So if it is detecting yawning for a longer period of time, then there would be an alarm which rings. The cases scale. The scale is used to tell us about what is the state of the driver. Although originally the scale has a window frame of 10 minutes, but for this project it was changed to 10 seconds so that it can tell on the frequent changes which take place, which the frequent face features changes that take place. So eye openness and mouth openness are used for the calculations of KSS, but both of these scales have different weights for the calculation of KSS, as they calculate differently to the drowsiness of the driver. So from hit and trial method, the eye openness was set as weight of 3 and mouth openness was set as weight of 1. The future improvements that can be there in this project is like different methods which can be used for calculations of KSS needs to be given a thought over. The complexion of the driver can also be taken into account because it helps us to determine the facial features like eyes more correctly compared to the present scenario that have been used. Uh, this project runs only well into the daylight because there is no LEDs which are included with the webcam. So the improved version could have the LEDs embedded with the webcam so that it can work into the night light too. Uh, the project is not able to track the very fast movements of the driver because the KSS window frame was set as 10 seconds, and it is not able to calculate such fast changes. This project is an approach to reduce the number of accidents caused by the driver drowsiness. This project first detected the facial features of the driver and then changed the 3D model into the 2D model and calculated the eye and mouth coordinates. ER and MAR ratio was calculated, and which in turn helped us to calculate the KSS ratio. KSS ratio told us the driver drowsiness state and was changed and the KSS scale was changed according to this need of this project, which was changing the window frame from 10 minutes to 10 seconds. This is the code which has been used for the driver drowsiness detection using the dlib library. It is a trained model in Python which uses the detector and the predicator to determine the faces in the video captured. The input for the project is taken from the webcam of the laptop. Finally, camera matrix and camera distortion has been calculated, and then 3D image points that have been captured is converted into 2D image points. For calculating eye aspect ratio, this formula is used. Similarly, for calculating mouth aspect ratio, this formula has been used. For all the faces that have been detected in the input, the following code runs, which in turn calculates projection matrix and rotation matrix. Finally, the Euclid angles are calculated to find out if the driver is facing the camera or not. ER ratio for left and right eye are calculated, and similarly the mouth aspect ratio is calculated. Then the weighted ER and weighted MAR are calculated to be used for the calculations of KSS scale, which in turn tell us the driver drowsiness state. This is the demo of my project. As you can see, it creates a rectangle box around the face, and the eyes and the mouth have been also marked in it. On the terminal, the calculations for cases goes on, and anything which is greater than 5 is considered as a state of drowsiness. So whenever I closes the eyes, the drowsiness level increases with time, and whenever it is greater than 5, an alarm rings. And similarly, it happens for the mouth. If there is yawning for a long time, the value is going to increase. And there is an alarm. You can also see that a message also comes over the screen whenever the ratio increases, which says drowsy, and the value of ER and MAR are shown on the screen. And this quits the program.